All right, in this video, we are going to verify the following identity. It is 1 divided by the quantity 1 minus cosine x divided by the quantity 1 plus cosine x equals 2 cosecant squared x minus 1. Okay, so as usual, I am going to start on the more complicated side, which is this left side over here. Here we have two fractions that are being subtracted. And so what we can do is combine these two fractions into one. Go ahead and subtract these. The issue, though, is that we can see that these two fractions do not have common denominators. And so we will need to get a common denominator first. All right, so we want to find the least common denominator. And looking at these two denominators, we want to make sure each of them is factored as much as we can. And we can see there's really nothing to do here in terms of factoring. 1 minus cosine x, there's no common factor or anything that we could factor out. So this is about as factored as much as it can be. And same thing here, right? If there were a greatest common factor, we might pull that out, or if it had some cosine squareds, we might try to be able to factor that as difference of two squares or something like that, but there's just nothing here. So both of these denominators are factored as much as possible, and there are no common factors. Here the only factor is 1 minus cosine x, and here the only factor is 1 plus cosine x. While those do look similar, they aren't exactly the same, right? And so therefore the common denominator, or the least common denominator, is just going to be the product of these two. It's going to be 1 minus cosine x times 1 plus cosine x. All right, so that's what the least common denominator is going to be. All right, so now that I've identified the least common denominator, what I'm going to do is go to each one of these fractions and ask myself, hey, what would I multiply this denominator by to get the LCD? Or equivalently, what is it missing from the LCD? So with this fraction over here on the left, we can see that it's missing the 1 plus cosine x out of the LCD. So what I'm going to do is multiply that fraction on the bottom by what it's missing from the LCD, which is this 1 plus cosine x. Now, I can't just multiply wherever I feel like it. In math, it would be a lot easier if you could do that, but it's not, right? So in order to keep things balanced out, I will also have to multiply the top part of the fraction by 1 plus cosine x to balance it out, okay? 1 plus cosine x over 1 plus cosine x is always equal to 1, right? Because it's the same number on top and bottom of the fraction. And, well, as long as this is 1's not 0, right? But then this expression wouldn't be defined, and so it doesn't really matter too much about that. As long as you're aware of that, right? So that's it. I'm going to multiply top and bottom by 1 plus cosine x on this fraction. All right, and then I have the minus. And then the next fraction I would do the same thing. I would look at this denominator and say, okay, what is it missing from the LCD? It's missing the 1 minus cosine x. So I'm going to multiply the bottom by 1 minus cosine x. Then I'm also going to multiply the top by 1 minus cosine x, the exact same thing that's on the bottom. Again, this will keep everything balanced out. I'm not going to change the value since I'm multiplying the top and the bottom by the same expression. Okay, so that's what I've got. And so now what I want to do is actually carry out those multiplications. All right, so over here on the left, I'm going to multiply 1 times 1 plus cosine x. That's going to give me 1 plus cosine x. On the bottom, I have 1 minus cosine x times 1 plus cosine x. All right, when I carry out these multiplications over here, on top, I'm going to be multiplying cosine x times 1 minus cosine x, right? To do that, I am going to have to distribute, right? That cosine x is going to have to be multiplied times the 1, and it's also going to have to be multiplied times the minus cosine x term there. So what I get is cosine x times 1 is cosine x. Cosine x times minus cosine x is going to be minus cosine squared x. And on the bottom, going to be the same thing. I have the LCD, right? 1 minus cosine x times 1 plus cosine x. All right, so now these two denominators, these two fractions have the same denominator, right? And so that makes it a lot easier to subtract them, because when you are subtracting two fractions that have a common denominator, you just subtract the tops and then put it over the same bottom. So when I go to subtract these, it's going to be 1 plus cosine x minus cosine x minus cosine squared x on top. And you may notice I put the entire numerator of the second fraction inside parentheses. That's because it is important to remember that this negative sign must be distributed to each one of these two terms. Okay? That is a common mistake that people forget, to distribute it. So most often they get it right with the first term, and then if there's multiple terms after that, they get that wrong. You must remember that this negative sign has to be distributed, right, to all of the terms on the top. Okay, and all of that is going to be over one minus cosine x and 1 plus sine x, or cosine x rather, sorry. Like so. Okay, so I've managed to combine the two fractions that are on the left-hand side into one big fraction. So I've got some simplifying that I'm going to do. Okay, so on top, right, I'm going to distribute that negative sign through the parentheses. And then I'm going to combine some like terms. Okay. And see what I come out with. All right. So let's go ahead and do that. So on top, I'm going to have 1 plus cosine x. All right, and again, I've got to remember to distribute that negative sign. So it has to go to cosine x and also go to 1 plus cosine squared x, okay? Or minus cosine squared x, sorry. All right, so I'm going to come up with minus cosine x and then plus cosine squared x, like so. Okay, when I distribute that. All right, on the bottom part of the fraction, I can go ahead and do some simplifying there, right? Here I have two binomials that I'm multiplying together, so I can use FOIL, right, to multiply those two out. So that's what I'm going to do. So first times first would be 1 times 1. Outer is 1 times cosine x. That would give me plus cosine x. Inner times inner is minus cosine x times 1. So minus cosine x. And minus cosine x times plus 1 cosine x gives me minus cosine squared x. Okay, so I've got some like terms in there, and I can combine those. I guess I'm going to go over here to the side and start working up. So looking at the top part of that fraction, I have cosine x minus cosine x. That will cancel each other out. So I have 1 plus cosine squared x on top. On the bottom, I have 1 minus cosine x minus cosine squared x. And so here, likewise, they simplify and give you just 1 minus cosine squared x. Okay, so so far so good here, right? We've done a lot of algebra and just kind of look for, we've combined this fraction and we've simplified it down to have this right here, okay? So the next question is, okay, where do we go from here? Well, here on the bottom, I have 1 minus cosine squared, right? So if I take a look at this identity, right, and rearrange the terms on this identity, if I subtract cosine squared from both sides here, I'll get sine squared x equals 1 minus cosine squared x. Like so. Okay. So again, here I'm just rearranging this identity. Okay, I'm not adding, subtracting, or multiplying and dividing both sides of the identity that I'm trying to verify. These are known identities that I know are true, right? So, so on the bottom of this fraction that I have, I can replace that with sine squared. So I'm going to go up a little bit. So on the top, I have 1 plus cosine squared x. On the bottom, I have sine squared x. Like so. Now, you may say, well, what about 1 plus cosine squared x? That doesn't look that much different than 1 minus cosine squared. Is there anything I can do with the 1 plus cosine squared? And the answer is, well, no, not really. You can see here, it looks like you might be able to do something with this fundamental identity, but when I try to rearrange it, I get 1 minus cosine squared x. So you're not going to be able to make this one into 1 plus cosine squared x in any way that's really going to be helpful in this problem. Okay, so so there's really nothing we can do about that, like this. All right, so still looking a little bit better than what we had before. So now the question is, where do we go from here? And again, I'm going to go up a little bit on this one. So what I'm going to do next is I am going to split this fraction up. Now you may say, well, look, we went to all this trouble, right, to combine this fraction into one fraction, and we got down to here, and now you're just going to turn around and split it back up? And the answer is, well, yeah, because that did give us something, right? Doing all that work got us down to this thing, which is much simpler than what we started with, but it's still not here. Remember, this is where we want to go. So what we can do is split this up. And when we do that, we'll get 1 over sine squared plus cosine squared over sine squared, like so. Okay? And we're going to see in a minute here, then that's going to be more close or closer to what we want right here, which is this 2 cosecant squared minus 1 thing. Okay. All right, so now where do we go from there? Well, we know, right, we want cosecant, and we know that 1 over sine is equal to the cosecant, right, by this identity here. 1 over sine, right, is cosecant. And so using this cosecant, if we square both sides of this, right? In other words, this is an identity, right? So we'll get the same value on either side when we plug a specific value in for x. Well, then we will get the same thing if we plugged it in when we square it, right? And so when you do that, over on the left-hand side, you get cosecant squared x. Over on the right-hand side, right, simplifying that, if I have a fraction being squared, that's the same as squaring the top, which would be 1 squared, over squaring the bottom, which is sine squared. Right, so that comes out to be 1 over sine squared. So we knew that cosecant was 1 over sine x. We can use that fact, since that's one of the identities that we can say, yeah, we absolutely know that that's true, right? We can use that and come up with this new identity that cosecant squared is also equal to 1 over sine squared, okay? Since these are ones that we are assuming are true, okay? So I'm going to make a little bit of space right here. So hopefully it doesn't look too cluttered. All right, and then moving up a little bit here, we can see that 1 over sine squared is equal to cosecant squared x, and that's looking good, right? Because that's involved in the identity that we want over on the right hand side, okay? And then we'd have this plus, and we could do the same thing that we just did for cosecant squared for cotangent squared. Right, we know that cotangent is cosine over sine. So if we squared both sides like we did over here on this, we would get cotangent squared equals cosine squared over sine squared. So very similar to this over here. And so that means that we can replace cosine squared over sine squared with cotangent squared. Okay? So that is looking pretty good, right? The only downside is that if we look and see what we've got or where we want to get to, right? 2 cosecant squared minus 1. We've got a cosecant squared in there. That's great, right? But this cotangent squared we don't want, because we know that's not in the identity, the expression on the right-hand side of the identity. So what we want to do is to find some identity that we already know that relates cosecant and cotangent. So looking through our identities, right up at the top in the Pythagorean identity, we can see that we have 1 plus cotangent squared equals cosecant squared. All right, and so that is the identity that we want to use. We will need to rearrange that, right, because what we have is just cotangent squared by itself. And the identity, the cotangent squared, is with that 1. So what we would do is just subtract 1 from both sides. And that would give us cotangent squared is actually equal to cosecant squared minus 1. Okay? And so that's what we're going to do. We are going to replace cotangent squared by cosecant squared minus 1. right here. So let's see, make a little bit more room over here. Okay, so all right, so this would become cosecant squared. Oops. Cosecant squared x plus, and then cotangent squared is cosecant squared. Golly, keep writing that. Cosecant squared x minus 1. There we go. So I'm replacing cotangent squared with cosecant squared minus 1. All right, and then the last thing to do is just combine some like terms. So, all right, and so here we can see we have one cosecant squared here plus another cosecant squared here. So therefore, that is 2 cosecant squareds. And then minus the 1. And that is exactly what we have over on the right-hand side. So that establishes the identity, or in other words, we verified that this identity is, this equation is in fact an identity. Okay.